Welcome everybody. We're going to do some algebra here, solving equations. This is for my Algebra 1A class. At the time of this recording, this is a required assignment, and I wanted to make this video because what IXL has, there's one type of question that we don't cover in class, again, at the time of this recording. So I want to show you at least one of those examples, but you can see the number up here. It's 55K. If you want that 3-digit code, there is a link to watch a video here on IXL, so you can see their explanations how they solve these problems. But we're going to start here. This is one we do cover in class, this first equation. 6 equals 3 times n minus 6. So process here, separate left side from right side. On the right side, we can simplify. We can simplify on the right. I can distribute the 3 times n. That's going to be 3n. That'd be technically a 3 times a negative 6, which would be negative 18, and we still have the 6 on the left. Now I can start canceling. I can't simplify the right side anymore, but I can start canceling. So I can add 18 to cancel the minus 18, balance my equation, and we will get here 24 on the left equals 3n. And we can divide by 3. And we'll have solved for n. We'll get n equals 8, or 8 equals n. Quickly, I'm going to do the check step. Let's check that real quick. If we put that 8 into the original equation, does it make the equation true? So I'm going to make the given parentheses big, and then I'm going to put the 8 in for n. I'll make those parentheses small. Is this true? So the thing to remember here, I don't need to distribute the 3. I have so many students do this. It's not wrong to distribute the 3, but you don't need to, because I can do 8 minus 6. I can follow the order of operations. Back up here, n minus 6, I can't perform n minus 6. So that's why I have to distribute. But here, 8 minus 6, I can do that. So let's do that. 8 minus 6 is 2. Is 6 equal to 3 times 2? Yeah, 6 equals 3 times 2. 3 times 2 is 6. 6 equals 6. So that's a good answer. Let's type it in, make sure that we're not making some silly mistake. N equals 8. There we go. We got it there. This is a very similar problem here. I'm going to skip ahead. And I think I'll just pause it. No, this is a good one here. Oh, this is a good one because we have the variable on both sides. So looking at the work that we can do here. 10F. Oh boy, I'm struggling here. Let's pause. Okay, there we go. That looks better. So 10F plus 10 equals 9F. We're trying to solve for F. So notice that if you look at the left side and the right side individually, the left side, 10F plus 10 does not simplify. Remember, it's not 20F. It's 10 flowers and $10. The right side is just 9F. So we cannot simplify. But I always like to check for that. Think about that. But now with the variable on both sides, the variables on the left side, the variables on the right side, get f, get the variable on only one side. Now it's your choice. Do you want to get the variable only on the left? Do you want to get the variable only on the right? Because of the dollars, the $10 on the left, and the right side just has the flowers, I'm gonna say let's just keep the dollars on the left. Let's only have the flowers on the right. So I'm going to subtract 10F. You can do that. That's the trick, is you can add or subtract the variable as long as you balance, as long as you do it on both sides. And then I'm left with a positive 10 on the left, and on the right, 9F minus 10F would be negative 1F. And then all I have to do here is divide by negative 1. And we'll get negative 10 would be equal to F. 1F, that's going to cancel there. I forgot to cross that off. Let's check that real quick. If we put, now here's the trick, is you're going to put that negative 10 in both places for f. So 10 times f is negative 10, we think, plus 10, and that's supposed to equal 9 times f, but we think f is negative 10. So is this true? Well, if I do my operations, I don't have to cancel when I check. I'm just doing the operations. 10 times negative 10 is negative 100. Plus 10, that comes out to negative 90. On the right side, 9 times negative 10, yeah, that's negative 90. So that seems like a good answer. Negative 10 equals F. I'm going to do this problem one more way just in case, for those of you that like to keep the variable on the left side and get rid of it on the right side. We'll go back here real quick. So same idea. We cannot simplify either side, but the variable on both sides. So for those of you that are, just like, hey, what if we subtracted 9f and cancel the variable on the right? That's not wrong as long as you balance. Subtract 9f on the left. But here's the trick. You got to be careful with this. You would have 1f, which is just f, 1f if you want. You'd still have the plus 10 on the left. The right side now is literally nothing. There's nothing on the left side there. So just be careful with that. Sometimes students will make a mistake and that 10 jumps the tracks. The 10 just all of a sudden jumps over to the other side, and students say, oh, f equals 10. I go, well, did you check that? Because that's not what I got. It should be 0 on the right. 9 flowers on the right, take away 9 flowers. That's all there was. So there's literally nothing on the right. There's 0. I would subtract 10 next, and that's where we're going to get the negative 10. F equals negative 10. So either way, it was quicker for me to cancel on the left. I guess in both ways it was kind of quick, but however you do it, you should always be checking your answers. So let's type that in, make sure IXL likes it, and then we'll probably do maybe one more here. All right, I'm going to skip ahead here to find a problem that has a fraction that's a little bit different. Again, at the time of this video, it's different than how we do in class. All right, so here's a problem that I was talking about where I probably should do more in class, but currently I don't do it very much. So it's got a fraction, which we know is division, but I want to think for a moment here about where the variable t and the minus 5.41, they're both in the fraction. So compare that to what if only the variable was in the fraction and the minus 5.41 was not in the fraction. These are different. These are different problems. When I do GMA instead of PEMDAS, we've got a group. The top of the fraction, this is a group. So this t minus 5.41 is part of a group. If we didn't have both of them in the fraction, I would add 5.41 to cancel that. But if you try to add 5.41 here, it doesn't cancel with the minus 5.41 because the minus 5.41 is part of a group. So it doesn't work, unfortunately. So you might say, well, how are we going to deal with this? Well, let me do a little bit of erasing, and then I'll share with you a couple strategies. So imagine for a moment that group on top here, if we just, instead of t minus 5.41, we just gave it a single variable. I'm going to choose a different variable, so not to confuse myself with t, but if I just called it x, all of that t minus 5.41, I just call it x. I go, well, how would you solve this? Well, I would say, well, it's division by 2. I will multiply by 2 to cancel that. Balance my equation. So in this case, I would get x equals, I believe that's going to be 4.18. And I would be done in that case. But here's the kicker. Here's the trick. Is that, remember, it wasn't x. My original problem wasn't x on top. It was t minus 5.41. So if I want to make this trade, that's fine. I just now have to trade back. So it would be t minus 5.41 equals that 4.18. Okay, so just I'm going to pause there for a moment because for some folks, some people, that might be kind of a blowing your mind sort of thing. But yeah, so I'm just momentarily kind of saying like, hey, t minus 5.41, what if we just called that a different variable, just x? All right, well then multiply by 2, and you've solved for that other variable. But now when I go, but it wasn't just x, it was really t minus 5.41, I go, I'm not done then. I have to now cancel that 5.41. So I would add 5.41 to cancel that. And then that's going to give me here, that'll be t equals, what is that? I think that's 9.59. You can double check on the calculator there. So a little bit different perhaps, seems a little weird. I'm going to give you another strategy to do this. Let's do the check step first here real quick. I'll do the check step in red. So if we check our answer, and then I'll give you another way to do it. So putting in 9 point, well, let me first of all check my calculation. Let me pause here. Okay, so I checked my calculations. They worked out to the numbers I had on screen. So now when we're doing the check step, going back to the original equation, remember order of operations. We have a group. That fraction creates a group on the top. So I need to, before I divide here, I need to do the subtraction. I need to do 9.59 minus 5.41, and that's going to be 4.18. We're still going to divide by 2, and I'm running out of space here, but it works out. 4.18 divided by 2 equals 2.09. So yeah, we're canceling division first here, which seems a little backwards. It seems like we usually cancel addition subtraction first, but that's because the subtraction is part of a group. So if that makes sense to you, being like, let's substitute x, let's put a different variable there, and then solve for that variable, then put the original back. Another way you can do it if you want, you got to be careful in this case because it doesn't always work out nicely. You can distribute the division, just like multiplication distributes over addition subtraction. You can distribute the division. I don't know if I can write this. Distribute division. So what happens here, where when you distribute multiplication, I call that the wink and smile. You know, you got a number times parentheses, and we do the wink and smile. This one I call the pretzel heart. So you could do t divided by 2, and then you could also do 5.41 divided by 2, which comes out to 2.705. The 2.09 is just hanging out on the other side. You can do that if you want to. I would warn against this because sometimes your division won't work out nicely. The 5.41 or minus 5.41 works out to exactly 2.705, but it doesn't always work out that nicely. So now you can add 2.705 to both sides. Let's see what we get there. 2.09. So you'd have t over 2. This would cancel. Whoops. You'd have t over 2 equals 4.795. And now you can cancel that multiplication, multiply by 2, or division, excuse me, cancel the division. That number times 2, I get the same thing. T equals 9.59. So depending on when you're taking this class with me, again, at the time of the making of this video, we haven't done problems like this on the quizzes. It's not currently on the test, but who knows, in the future it might be. But either way, I get 9.59 rather, 9.59. Checked that already, so that seems to be a good answer. Again, however you're solving this, you should be doing the check step. You should already have an idea that you think your answer is good or you think your answer is bad before you submit there. But let's try it out. All right, well, I hope that video was helpful for you. Again, you've got this IXL assignment has a video that you can watch by IXL. But yeah, keep practicing. Practice. We'll see you next time.